All right, guys, number 6, we're supposed to find the inverse of f of x. All right, so this is one of those problems. Quite frankly, this has not made the list the last few years. The whole 80% or less success rate. This was one a few years back, and I think that in part it was that I wasn't formally reviewing it, ahead of time. This is just one of those things that it's a little pattern. We just have to somewhat memorize how it goes. I'd like for you to think about this in terms of bigger picture, though. When we're talking inverses, what are we doing with our domain and range when we're talking about the inverses? Yeah, the domain and the range, they're literally trading places. So the way that we think this through, though, and hopefully the way you think this through, is that you're literally trading x's and y's. So if you have a function f of x, and we have this point at 2, 5, we know that the function f inverse of x is going to have that point flipped at 5, 2. Okay? That's absolutely what's going to happen. It's not a sometimes, but an all the time thing. So how does that translate to a problem like this, where there's no graph, and that's not the expectation whatsoever? But we're still going to do the same thing. One slight adjustment. Instead of f of x, we're going to go back to saying y equals x cubed plus 5. And we're literally going to trade the places with the x's and the y's. So we're going to rewrite this as x equals y cubed plus 5. And now my focus is to get y all isolated all by itself. So if I subtract the 5 over, x minus 5 is equal to y cubed. I don't want y cubed, I want y. So I'm going to cube root both sides. So now we have y is equal to, again, the cube root of x minus 5, which looks like D is the winner there. All right, guys, remember a problem like that? And hopefully you agree with me when I say it's not super complicated. We just have to remember that that's the way that we do it. We set it up, switch places with the x's and the y's. All right, number 7. This is one that I remember distinctly the first time that I saw this on the list, thinking, gosh, how did this one end up there? But the more I looked into it, it actually makes a lot of sense. Jackson. Are C and D? Oh, yeah. So I was going to say, yeah, so the -5 on number C, -5 would be a constant. It's not under the cube root. Okay? Very good point, though. Yeah. And honestly, that's the type of thing I'm pretty sure has come up in the past as far as why somebody would miss it versus get it correct. Again, a lot of you guys did the ACT this past weekend, probably, right? Anybody who did the ACT? Okay. It's going to be the same type of thing. Less pressure, I would say. I hope you're not putting as much pressure on yourself to do this test as the ACT. What's that? Yeah, no, I agree. But what I'm saying, though, is that we're going to be doing a multiple choice test, and there's time is on the line type thing. So, yeah. All right, guys, number 7, though. This one, like I said, on the surface doesn't seem like something that we would struggle with, but there's a little bit of a twist to this problem. So we're supposed to find all of the real zeros. So remember, the way that we go about finding the zeros is that we put a 0 in for f of x. So what this is really going to say is 0 is equal to x times x plus 1 times x to the 4th minus 64. Now, remember the way that we set this up is that if I'm multiplying, I'm just going to set each equal to 0. So I have x equals 0. Well, there's my first 0. Here we have x plus 1 equals 0. So I now know, that x is equal to -1. Those were not the issue. The issue came here with x to the 4th minus 64. All right, so if I set that equal to 0. All right, so guys, please don't hear the wrong thing here. I want to be very intentional how I say this. What I'm about to do isn't wrong. Not at all. But what a lot of people have done and led to issues is they added this over, x to the 4th equals 64. Then they used their calculators to, that's not cube root, sorry, but 4th root, to get that x is equal to, and your calculator is going to give you something like 2.8. Not doing anything wrong, that's correct. The problem is that on the test booklet, decimals aren't going to show up in the answer choices. It's going to be in terms of radicals, reduced radicals and things like that. So again, if you're given a bunch of radicals, by the way, this is plus or minus, I want to drop that. If you're given a bunch of radicals and you did the work in decimal format, should you be able to make the translation? I would hope so. If you see, oh, the answer choice is 2 root 2, is that the same as 2.8? I would hope that you could type that into your calculator to check. But a lot of people obviously didn't do that. They panicked once they got decimals, thought, oh crap, I did this wrong, and then I think they guessed from there. Don't do that if that happens to you. We can avoid that. Excuse me. We can avoid that by simply recognizing that what we have here with x to the 4th minus 64 is a difference of 2 squares in your dots, where the square root of x to the 4th, x squared here, the square root of 8, negative and positive 8, like this. Now when we set this up, x squared minus 8 equals 0. I add the 8 over, x squared equals 8, square rooting both sides, and now I know exactly how that's going to break down root 4 root 2. So x, and I'm sorry, I dropped it again. That's twice in a row. Can't forget my plus or minus. So plus or minus 2 root 2. I struggled today. So there are 2 more zeros. When we jump over to the other side, we have x squared plus 8, equals 0. When I subtract it, though, x squared equals negative 8. Square rooting both sides, and we're running into a problem now, aren't we? What's the problem? Yeah, it's not that we can't go any further. It's just that we're supposed to find the real zeros. So this is not going to lead to any real zeros. We have them. We have 2, 3, 4 answers. Quick question, though. If we were to go back to the very beginning, what was the degree of that function? It's not 4. It would have been 6. So did we do something wrong? Because we only found 4 zeros. Yeah, 5 and 6 would have been there as imaginaries. We were only supposed to find the real ones. So no, we did that properly. All right, does anybody have any questions on that? All right, number 8, asymptotes. What time are we out of here? About 2 minutes? Awesome. All right, so guys, asymptotes. Good news and bad news regarding asymptotes is that I guess the bad news is that there's some memorization involved. The good news is that the problems themselves are relatively easy. We have 3 types of asymptotes. We've got the vertical, the slant, and the horizontal. All right, so the vertical asymptotes, remember the way that we do that is we take the denominator, set it equal to 0. So in this case, I'm going to factor x plus 2, x minus 2, set that equal to 0. And now I can say that my vertical asymptotes are going to be at positive and negative 2. Everybody's good with vertical asymptotes?
Yeah.
All right, slant asymptotes. They are going to exist only if the numerator's degree is 1 larger than the denominators, and that's not happening in this problem. So no slant asymptotes, which is going to open up for the horizontal asymptote. So now we have a couple of different scenarios. So if the numerator's degree is larger than the denominators, it's impossible to have a horizontal asymptote. Cannot exist, will not happen. Okay? What happens if the degree of the numerator and denominator are the exact same? Again, not what we have here, but if we had 5x squared, I heard leading coefficient test. I'd say 5 is my lead coefficient of the numerator, 1 is lead coefficient of the denominator, so y equals 5 would have been the horizontal asymptote. But again, that's not the scenario that we have. Instead, if the numerator's degree is less than the denominators, automatic, y equals 0, the x-axis is our horizontal asymptote. All right, guys. We're going to pick up with number 10 tomorrow. Have a great day. I would encourage you to at least check into the blue packet for tonight. Have a great day.